Hey everyone, it is Gabe from Babylon Journey, and we are diving into episode 2, and we are getting into lights. Now, you might remember from the last episode, we made this thing, which was just in about 30-40 lines of code. We made this little scene with a reflective 3D model. All very good, but now we are diving deeper. We are going to make this demo, which actually has a little user interface for switching between a few different lights. So the goal is to learn about the different kinds of lights you have access to, and also to actually use those lights, put together a demo with those lights in a scene that lets the user switch between a couple different types of lights. So let's dive into it. I am fired up. It's going to be a big week for the industry, by the way. Maybe a quick ramble about this, but rumor has it that at Apple's Worldwide Developer Conference on the 5th, they are going to reveal some immersive hardware, whatever they might be calling it, Apple Glasses or XR or Reality Pro or what have you. But relevant for us is the fact that the skills that you're learning during this series, Babylon Journey, will be skills that you can directly apply to building websites that run from this hardware. The reason I think this is because if you've been following Safari, they've actually been working on WebXR support for the Safari browser. Now, WebXR has been in Chrome for a while. It's been in Edge. It's been on the browser that's on the Meta Quest headset. Safari WebXR support has been kind of bad or non-existent up till now, but they've been working on it. This leads me to think that Safari will actually be a WebXR capable browser for the Apple immersive hardware. Now, we're going to get into augmented reality in full later in the series, but it's not like we can just jump into that, or that we should just jump into that. Like, these fundamental things you're learning in the other episodes are going to be foundational skills that then you can apply to building your augmented reality experiences with Babylon JS. So I hope you're excited. I'm excited. Now, industry ramble aside, let's dive into learning about lights. Okay, now just as before, I've got a starting code sandbox that you can fork that just has the beginner kind of boilerplate and the imports and a few of the things that we set up last time, basic engine creation and scene creation and making a camera. And then I'll also have a final code sandbox if you just want to fork the final result, the final demo, and then tinker with it. That's totally fine too. Both those links will be in the description of the YouTube video. Okay, now the setup I have in here, of course, in my package JSON, I've installed Babylon. In my index HTML, I've got this canvas. This will be old news to those who saw episode 1. And in my index.js, I've got a couple imports from the Babylon libraries. This time, you'll see a few new ones, like these light classes, hemispheric light, point light, directional light. We're going to get into this. And then I've also done just the basic scene setup boilerplate, like grabbing a reference to the canvas, making that Babylon engine with the new engine, making the Babylon scene, making the camera, right? These three things we went over last time, engine, scene, camera. I've already got them built. I figured we don't need to go over it again. I'm running the render loop, and I've got this little event listener on the resize event so that if a user resizes their browser, the engine will resize with it, keeping a nice smooth experience. All right, let's dive into lights. Now, lights are really important for any 3D stuff. Like, lights really add a layer that people often don't pay too much attention to, but it makes the difference between a scene that looks okay and a scene that just looks gorgeous. So it's something you want to get your head around. We're not going to dive into all the nuances of lights in this episode, but I want to give you a high-level overview of the different light types and how to use them. Okay, let's get into it. Let's start with a directional light. So let there be light. Let's code it up. We're going to go with a constant directional light. And just like with engine and scene, these are class constructors. We've already imported the class. We can just say new directional light. Now the constructor takes a few arguments. The first one is the name for the light that you're making here. We're just going to call it directional light, no big deal. And then you pass in a vector, a vector 3. And this defines the direction you want your directional light to go in. Directional light comes from everywhere, but goes towards a particular direction. If it was coming from the top, then the top of your 3D models would be lit up. So this is where you actually pass in that vector. And I'm going to say new vector 3. Vector 3 takes 3 arguments, x, y, and z. Remember, we're in 3D space here. X, side to side, y, up and down, z, forward and backwards. Simplification, I know, but working with it for now. So for the direction, let's go with 0 and -1 and 1. Now, -1 will actually give it that downward, where you think about the y-axis up and down, negative in the y-axis is downwards, right? And vectors are actually directions. And we'll get into more about vectors later. And then finally, 1 on the z-axis just puts it a little bit behind the camera at first. Now, we'll see the effect of this directional light soon in our demo. Our demo is all about being able to actually visualize the difference between these lights. All right, next up, though, let's make a hemispheric light. Now, same deal. It's a class. So we're just going to say new hemispheric light. And we pass in a name. We're just going to call it hemispheric light. And we pass in another vector. Now, a hemispheric light is sort of like an ambient scene light, okay? And the vector you pass into it is more about the way that the light will reflect off of your models. It's the direction the light will reflect off of them, rather than like the direction of the light itself, because it's ambient. Like, it's not coming from a particular direction, it's coming from everywhere. But this vector 3 you set here will be like the way the light bounces sort of off of your models, the way it'll be reflected. So for this, let's do 0 and 1 and 0, right? Reflect it like back up. 1, positive in the y-axis. And then I think I forgot in the last one, but we do also want to pass in our scene here. So we're going to say scene. Oh, not a dot, I want a comma. Perfect. Okay, that's 2 lights down, and we've got, I think, 2 to go. The next light, let's make a point light. Okay, you are getting the picture so far. It's just new point light, and we're going to call it point light. And the vec3 for a point light is actually the position where we want the light. Okay, so for our point light, let's say new vector 3, and we will pass in 0, 1, 0. So the point light will be basically at the origin point of the scene, but up 1. Now, a point light is like a light that just radiates a little bit of light from it in every direction, sort of. Just like kind of imagine like a night light, where light is kind of radiating off of it from a particular point. That's a point light. Okay? And then let's also pass in our scene before I forget. Okay, lovely. Now for the last light we're going to do here in this lesson, it's a spotlight. So we're going to make a const spotlight, new spotlight. Now spotlight takes a few more arguments, and that's fine. We're going to go over each one right here. So first off, a spotlight, imagine like at a concert on a stage, the effect of a spotlight. It's a light that comes from a particular direction, from a particular position. It's going in a particular direction. It has a certain field of like light. It could be real narrow or it could be wider. And it has a certain like intensity, right? How far the light will actually go in space. So we can set all of those right here in the constructor. We're going to do so now. The very first one is the position of the light in the scene. For starters, we're going to put it up high a little bit, 10 on the y-axis. All good. For the direction it's going in, I just want to direct it kind of away. Well, let's direct it downwards. So we can just say -1, 0. Okay. And let's define its kind of angle, how wide the angle is that the light emits from. Imagine if this was really small, then the light would be kind of a narrow beam. But if it was really wide, it'd be kind of this big, broad spotlight. And we're going to keep it, we're going to do math.pi divided by 4. Now I'm going to get into why math.pi works for like radians like this, when you're defining an angle in radians, but it's for another lesson. For now, trust me on it. You can experiment with your own value in here to see, to try out other numbers. But I promise, stamp this. We will get into this more later. And then finally, the exponent, like how sort of far we want the light to go before it dies off. And I'm going to pick 1 for this, okay? And then I think we also pass in our scene. All right, lovely. Okay, phew. So we have set up our lights. Now, the other thing we want to do is let's give these lights some colors, okay? Maybe I'll even get rid of these spaces. Bye-bye. Here we go. Okay, now let's give these lights some color. Now, there are two kinds of color with lights that we can mess with. One is diffuse and one is specular. And we're going to mess with the diffuse right now. Diffuse is kind of like generally the color that objects will have when they're affected by this light. Specular is a little bit more specific and has to do with a specific way that the object reflects the light from a certain angle, kind of like the glancing reflection. I'm not explaining this very well, but this image hopefully helps a lot more. So think about, it says here, the zone of light for this is like diffuse. This is like generally how this ball is illuminated by the light. But then here, this little dot that you see, this kind of like glancing reflection of the light at a particular point, usually where the object is actually facing the light, it's got this specular reflection. Now, we're not going to mess with specular reflection. We're not going to mess with the default specular reflection value, but we are going to mess with the diffuse color of the light, okay? So let's go back. For our directional light, let's give it a color. We're going to do directional light.diffuse, okay? Equals new color 3. Now, what the heck is a color 3? A color 3 in Babylon is the way that you basically set up like an RGB color definition, and you can do color 4, by the way, if you've got an alpha value for RGBA. But it needs these values to be on a scale of 0 to 1. So you can just take your RGB color values and divide each one by 255, and you'll end up with the values that you can plug into your color 3. Now, Babylon has a few helper functions for like converting hex to color 3 and RGB to color 3. But for now, that's just kind of the shortcut. Like if you already have an RGB value, just take each one, divide it by 255, I think, and you'll end up with the values you can plug into your 3 parameters here for the color 3. All right, now for the hemispheric light, let's give this a diffuse color of, let's say 0.5, 0.5, and 1. And then for the point light dot diffuse, let's give that a color of 0, 1, 0. Now, this pretty much, I believe, will make the point light green, right? RGB. So if R, red and blue are 0 and green is 1, then that would be green. And then let's go spotlight.diffuse equals new color 3. We're going to say 1, 0, 1. Which is red and blue. I think that'll end up like a purple spotlight with no green in there. All right, perfect. Okay, now I know this video is going to be a little bit long, but it's because we want a little user interface for our users to give them a way, and you, to toggle between these different lights in the scene to help you really visualize how the different lights work in the scene. To do that, we're going to get into the Babylon GUI system. And we're going to have a whole bunch of episodes just on Babylon GUI, I promise. So kind of bear with me for now as we set this up. I will get into more detail on this later. First thing we want to do, let's make a full screen UI. It's kind of exciting stuff. I know, a little like side quest here. This is called an advanced dynamic texture in Babylon. Is kind of the class you use to set up these user interfaces. And it's got a method on it called create full screen UI. A little helper just helped me out right there. And we're going to give it a name, UI. Okay, perfect. Now again, I'm going to rip through this pretty fast. All I want is a simple text block. I'm going to say text equals new text block. Okay. Another class. We've just made a text block. Perfect. Now for the text itself, that's like the text property of the text class. I know text.text is weird, that's my bad, but I'm rolling with it. Let's say, what buttons do we want the user to push to change between toggling these different lights? Let's say 1, 2, 3, 4. So we're going to say press 1, 2, 3, 4 to switch between light types. And then let's actually let them know what the current light type is. Current light, when it starts off, it's going to be all, right? All of them are going to be enabled at first. Okay, lovely. Let's do text.color. Let's make that text white. Let's do text.font size. Let's make it 24, making our little GUI here. We need a control to put the text onto. You need like a panel to put the text onto. Let's make a panel. This is going to be another class from the Babylon GUI called rectangle, which, as you might guess, is just a rectangular panel you can put GUI elements onto. Okay? We're going to do panel.width equals 0.7. That'll be 70% of the available width of the canvas. We're going to do panel.height. We'll hard code this in pixels. So it's going to say 70 pixels. We are going to give it a color. Let's say black. You remember we made the text white. This will give nice contrast. And let's give it a thickness 2 and a background. You know what? I'm not even sure we needed this color property. It might just be this background that we need. Let's get rid of color. Panel.background is black. And then we're going to run this method, add control, right? To the panel, we want to add our text, okay? And I want to kind of put the panel all the way at the bottom of the screen. So I'm going to give it this property vertical alignment. And you can say control vertical alignment bottom. And you'll got to import the control class to get this little helper. You can do bottom, you can do top, you can do center. In this case, we want bottom. You can also do this horizontally, but I think we'll be okay horizontally. And then finally, grab our UI constant that has this advanced dynamic texture, this full screen UI. Grab it and do add control panel. So in a nutshell, we've made our big full screen UI. We've made a text block. We made a panel. We added our text block to our panel, and then we added our panel to our UI. Let's see what that actually looks like, which I believe we can do now in our preview. Okay, and here it is. Here's our little UI panel with the text as we set. Here's our Babylon scene. And you might be thinking, well, where are our lights? We already made a bunch of lights. And the answer is, well, they're here, but you can't really tell because they're not lighting anything up. Like, lights actually need things to get lit in order for them to be apparent. So we need some actual stuff in our scene kind of responding to these lights in order to notice them. So let's go in. We're going to make an empty array of primitives. And primitives, you know, things like spheres, boxes, cubes, kind of like generic little shapes. We're going to make an empty array, and then we're going to populate it. We're going to do that with a for loop. We're going to run some code like 30 times. So I'm going to say for let I equals 0. Let's say we want, how many shapes do we want? Maybe 30. And then increment to run our for loop 30 times. All right, lovely. So what code are we going to run 30 times? Well, I want to make a bunch of stuff. So first, let's do sphere equals mesh builder.create sphere. Now these are like helper functions that Babylon has for creating these primitives, like create sphere, create cube, create box, create polygon. They even have some pretty sophisticated ones. We're just going to use create sphere for now. I think you can actually import create sphere directly. I've imported mesh builder, but either way is fine. And we're just going to call each one, like, I don't even think we really need to give them names. I'm just going to give them empty names. We can leave the defaults in all these values for the segments and diameter and things like that. We can just pass in our scene. Okay. Now I want to give, if we make 30 spheres, they're all going to show up in the same spot unless we set their position. And I want to give them each a different position, right? I want them all to be kind of scattered around a little bit. So I'm going to say for each sphere, this is going to loop through 30 times. Let's say sphere.position equals new vector 3, as we're used to seeing our good friend vector 3. And let's get a little bit of randomness in here. I'm going to say math.random times 20. And then I had played this value before, and at the end of the day, to keep most things in the viewport, I then want to do -10. Now you can toy with these values. I really encourage you to see how that impacts the where they end up on the space. So that's just I've only set the x value in my vector 3, right? It's x, y, and z. Let's make y and z a little bit random as well. Now math.random returns a value guaranteed to be between 0 and 1. It's not like a random number of all the possible set of numbers, so it's relatively constrained, which is what we want. So for each one of these, let's just do the same kind of randomizer function. Times 20 minus 10. And that's our vector 3. Okay, and I did something wrong here because my braces are out of whack, so let me see what I did. Looks like that. And now we are golden. Okay, lovely. Okay, we also want to push these into our primitives array though. So I'm going to go loop back to this primitives array and do primitives.push sphere. Okay. So we're kind of like creating these spheres, 30 of them, and when we're also adding them to this array of primitives so that it's easy for us to reference them later in our code. We're going to loop through that array later. All right, let's also make some boxes though. Now I'm going to do this quickly and probably just speed it up in the video itself so that you don't just have to hear me bore you to death talking about how I'm filling in these variables. Okay, I think I've made 30 spheres, 30 boxes, 30 cylinders, and I've pushed them all to the primitives array. I think we should actually see them now start to show up. Okay, nice, and here they are, rotating around. Look at all these different colors. You might be thinking, what's going on with all these colors? Well, remember, we set a bunch of different colors for our lights, and all of the lights are on right now. So the primitives, these meshes, are getting this wild combination of all these different colors from all the different lights that are in the scene. And this is what our UI is going to do. We're going to make it possible for the user to toggle the different lights so that they're not all on at the same time, but just a certain particular one of these lights. So you can really see each one's individual effects. Let's dive in. We're in the home stretch here, I promise. Okay, lovely. So we are going to turn off this preview. Let's get back into it. We need to set up like an event listener, right, for a key down event. So fair enough, we can do window.add event listener. Just some basic JavaScript here. We're going to listen for that key down event. This isn't Babylon specific stuff. This is just browser specific stuff. This is just JavaScript. We're listening for a certain event. And really with any key down, we're just going to go like brute force. With any key down, let's disable all the lights straight up. So we're going to loop through, just each of our light types. Directional light, which, these are constants that we set up above, right? This is why we did that, so that we can reference them down here. Directional light, set enabled false. And let's do this for each of our light type: spotlight, point light, and of course hemispheric light. Okay. Then let's make a switch statement for different keys that are in the key down. A switch statement kind of lets you perform different, execute different code based on a variable that might be different. In this case, the variable that might be different is event.key, like which key is pushed. If you need to review switch statements, just Google switch statement JavaScript. So we're going to do a switch statement. In the case of 1, then we are going to turn our directional light on, set enabled, true. Now that's what this set enabled function is doing. This is a Babylon function on these classes. And if you do set enabled false, it turns that thing off in the scene, right? It disables it in the scene. But then to bring it back to life, you can do set enabled, but pass in true. So when we first get a key down, we're just going to turn off all the lights. Boom. And then if it's a certain key, we'll turn a particular light back on. In this case, the directional light. 1 is going to be turn on the directional light. And then we're also going to update our text because the text in our UI, if you remember, it kind of says current light, it lets the user know what is the current light that's enabled. Right now it's all, and we want to fix that. So we're going to say text.text. We're honing into the text property of the text box, and it's a variable I should not have named text, but I did. So we've got text.text equals, it's the same bit of, press 1, 2, 3, 4 to switch between light types, but now the current light is directional light. Directional. Okay. Okay, and we also need a break at the end of each one of our cases. Now for the rest of the light types, let's just go ahead and copy and paste this. We need the other, like when you push the other buttons, 2, 3, or 4, we want the other lights to turn on instead. So for case 2, that will be our hemispheric light, where we define these as constants up above, which is why we can access them like this. Say hemispheric. For case 3, that'll turn on the point light. So we'll say point light, set enable true, grab that, current light point. And then for case 4, last but not least, that will be our spot light. Current light, spot. And then break, and then I believe we need to make a, if any other key is pushed, it's not covered by our switch statement, some other key pushed in the console logs. Okay, great. Let's close up that switch statement and then also close up our event listener. So to recap, when the user pushes a button, this event listener fires, we disable all the lights, and then we listen, okay, if that event.key, this is just JavaScript for this will tell us which key was pushed. If it was a 1, then we turn on the directional light. We update the UI text. If it was a 2, the hemispheric light, 3, point light, and 4, spotlight. This will let us isolate each light individually. Let's go ahead and save this, and let's check out our preview. All right, here we go. Boom. There is our directional light, and you can tell it's directional because look, it's going in this direction. You can see they're all lit up from this side. From the other side, no dice. Hemispheric, look at this. So this is that ambient light, right? They're all kind of lit up, and we changed the colors of the lights early on in the lesson. It's all like coming together now. But then at the bottom, they won't be lit, right? This is all about this hemispheric light and the light, this kind of ambient light. Okay. Now, point light, check this out. So imagine, right, a little light kind of in the middle of these primitives, and it's lighting them up, but kind of like more of a night light effect. It's light radiating from a point in the middle there. And then, last but not least, our spotlight. Now, the spotlight isn't that dramatic because it's just pointed a particular place right now, and we don't get that kind of spotlight effect. And to see that, we'd actually want to animate the spotlight, which we're going to do now in the home stretch. I know this video is probably like a half-hour long by now, but we're going for it. We learned a little bit about animating in the on-before render observable in episode 1, and we're going to leverage that right now yet again to make this demo even better. So let's go ahead and do it. Okay, what I'm going to do is make a counter. I'm going to say let counter, and it's going to start off as 0. We're going to use this counter. And then just like we did in episode 1, we're going to do scene.onBeforeRenderObservable. This is like, this will fire before every frame gets rendered. It's going to fire a lot. It's good to use for things that happen frequently, like in this case, this animation. Okay. So onBeforeRenderObservable, when that happens, we're going to increment our counter. Okay. So this counter is just going to keep going up and up and up. We're going to increment it by 0.01. Okay. Then remember that up above, when we made our primitives, I stashed them in an array of primitives, right? All for this big loop, all these spheres, boxes, cylinders got pushed into a primitives array. Well, I did that for a reason. It's because now it's easy for us to loop through that array to perform actions on all of these meshes. So I'm going to go primitives.for each primitive, and we're going to get the index. This is just a regular like for each loop. Missed a braces here. For each, So for each primitive, what do we want to do? Well, I want to actually change I want all the primitives to be moving around a little bit to give us an even more dramatic effect. Then we'll do the same thing with the spotlight. So let's, for each position, like primitive.position.x, let's increment it. And what we're going to do is use math.sin, sine. We're going to get like this oscillating sine wave pattern. And I want it to be a little bit different for each primitive. That's why I got the index here. Right, its index in the array will be like 0, 1, 2, 3. It's a number that's guaranteed to be different for each primitive. So we're going to say index plus counter divided by 100. Now we're going to get into kind of sine waves and cosine and all this stuff. And in fact, the Babylon crew, they have some really good videos. Jason in particular has a great one on kind of like understanding this. And I'm not a super great like math whiz, I just want to say. What I do know is that this is a way to get kind of like a nice, smooth, like oscillating pattern that's relatively controlled. Like when you run math.sin on a number, like you're guaranteed to get something in between -1 and 1, and that's what I want. So the counter makes sure that it stays smooth, right? Because we're smoothly kind of updating this on every frame. Okay, we're going to do this for, I'm just going to go ahead and do some copy pasta, because I want to do the same thing, really, for Y and Z. Okay, lovely. Now, in fact, just to mix it up a little bit, instead of sine, we'll do cosine for the Y value. Just add a little bit of variety into the mix. Okay, cool. Let's wrap up this for each loop. And as I mentioned, we want to animate the spotlight as well. So I'm going to do if spotlight.isEnabled, which is a function that you can use to check whether something is enabled or not. Remember, we used this set enabled false and set enabled true to toggle whether something was enabled. Well, you can check it with isEnabled. So we want to say, look, if the spotlight is enabled, then we want to do some stuff. Primarily, we want to animate the direction of the spotlight. I want to see this spotlight moving around. So, you can animate like anything in here. And there are lots of ways you can animate things, but I just want to emphasize it's not just position, rotation, and scale that you can put in here. You can put anything in here. So this is a vector 3, and let's give it a nice little oscillation with, we'll do math.sin again, pass in our counter, and -1 on the Y and 0 on the for the Z value. So I think this should kind of make it sort of be going like side to side to some extent. Let's see how it does. And I need to wrap it up. I got my final closing braces. Let's see how it does. Wow. Okay. Look, we've got all of our meshes, all of our primitives moving around in a really cool way. We did that with this right here in the onBefore render observable. And look how kind of this smooth back and forth motion that they're taking, right? That's because of sine and cosine and stuff. But then we can actually use our user interface. Press 1, there's a directional light. And it's coming from this direction, clearly, right? See how everything's lit up this way? From here, not so much. Hemispheric, got this full ambient light that lights everything up all over the place, really, besides from the bottom. We've got a point light, which is kind of in the middle here, radiating light out. And then we've got our spotlight, which now is actually moving around. Look at that, because we're animating its direction. Okay. This video was a little longer than I hoped, but we got into some other topics besides light that I hope were valuable. We did a little bit of UI work with the Babylon GUI system. We did some more animating. Went on a ramble about augmented reality in the beginning. Hopefully it was all helpful. Okay, great. I have the final code sandbox of this demo linked in the YouTube video, as well as the starting code sandbox, which you can use as you go through it. More coming soon. Thanks.